chapter, we will discuss about basic concepts of aerial photography, factors influencing aerial photography, classification of aerial photographs, obtaining aerial photography, remote sensing and aerial photography. Photographing from air is basically known as aerial photography. The word aerial derived in the early 17th century from Latin word aerius and Greek word aerios. The term photography is derived from and geographical meaning writing means writing by light. Aerial photography comes under the branch of remote sensing. Platforms from which remote sensing observation are made are aircrafts and satellites, as they are the most widespread and common part of remote sensing and wide applications in topographical mapping, engineering, environmental science studies and exploration for oil and mineral etc. In the early stages of development, aerial photographs were obtained from balloons and kites, but after the invention of aircrafts in 1903, aircrafts are being used widely for aerial photographs. Aerial photography in simple terms means photography from the air. Aerial photography is one of the most common, versatile and economic forms of remote sensing. Aerial photography was first method of remote sensing and even used today in the era of satellites and electronic scanners. Aerial photographs will still remain the most used type of remote sensing data. Aerial photography consists of taking photographs at regular interval from an aeroplane flying along a definite line at certain height above the ground level. The sun provides the source of energy, that is electromagnetic radiation or EMR, and the photosensitive film acts as a sensor to record the images. Diversifications observed in the images of the photographs shows the different amount of energy being reflected from the objects as recorded on the film. Nowadays, aerial photography also became digital, where values of reflected electromagnetic radiation is recorded in digital numbers. An aerial photograph is a photograph taken from an airborne vehicle such as aircrafts, drones, balloons, satellites and so forth. The aerial photographs has many uses in military operations. However, for the purpose of this manual, it will be considered primarily as a map supplement or map substitute. Basic concepts of aerial photography. Film. Special areas which is captured by a camera are represented in the form of a film. Mostly black and white films are used in aerial photography, but infrared, colored and false color infrared films are sometimes used in the spatial projects. Focal length. Distance from the middle of the camera lens to the focal of the plane. As focal length increases, image distortion decreases. The focal length is precisely measured when the camera is calibrated. Scale. The ratio of the distance between 2 points on the photo to the actual distance between the same 2 points on the ground. Scale may be represented in 3 ways: uni-equivalent, representative fraction and ratio. There are 2 types of scales in broad scale, that is large scale photos which cover small areas in greater details, whereas the photo is simply means the ground features are at large, more detailed size. The area of the ground coverage that is seen on the photo is lesser than its smaller scale. Small scale photographs, example, more than 1:250,000 cover large areas. Since less detail is small scale photo simply means that the ground features are into smaller, lesser detail size. The theory of ground coverage that is seen on the photo is greater than that of the large scale. Fiducial marks. Small registration marks exposed on the edges of the photographs. The distance between the fiducial marks are precisely measured when the camera is calibrated, and this information is used by the photographs when compiling a topographic map. Overlap. Overlap is the amount by which one photograph includes the area covered by the other photographs and is expressed as a percentage. The photo survey is designed to acquire 60% forward overlap, that is between the photos along the same flight line, and 30% lateral overlap, that is between photos on adjacent flight line. Stereoscopic coverage. The three-dimensional view which results when to the overlapping photographs called stereo pair are viewed using stereoscope. Each photographs of the stereo pair provide slightly different view of the same array which brain combines interprets as a 3D view. Roll and photo number. Each aerial photo is assigned a unique index number according to the photo's roll, and for example a photo A238235 is the 35th annotation photo on the roll A23822 flight lines. An index map at the end of the photo machine. The aerial survey contacts plots on the location for the first and the last, and every fifth plot along with its roll and frame numbers. Photo centers are presented by small circles and straight lines are drawn connecting the circles showing the photos on the same flight line. This geographical representation is called as photo index map, and it allows to relate the photos to the geography location. Factors that influence aerial photography. Scale. Scale is defined as the ratio of distances between two images on an aerial photograph and the actual distance between the same 2 points or objects on the ground. In other words, the ratio of f by h, where f is the focal length of the camera lens and h is the flying height above the mean terrain. Change in scale from photograph to another is because of the variation in the flying height. Other factors that further affect the scale variation are tilt, relief displacement. Aerial photographs, the image should be of highest quality. To guarantee good image quality, recent distortion-free cameras are used. Some latest version of cameras have image motion compensation devices to eliminate or reduce the effects of forward motion. Depending upon the requirement, different lens, focal length, film, filter combination can be taken in use. Camera, film, filter combinations. Aerial cameras. Aerial cameras are special cameras that are built for mapping which have high geometric and radiometric accuracy. Airborne cameras are built with exactness and purposely designed to expose a large number of films or photographs in a speedy succession with the ultimate in geometric fidelity and quality. Aerial cameras generally have a medium to large format with good quality lens, a large film magazine, a mount to hold the lens, the camera in the vertical position and the motor drive. There are various types of aerial cameras such as aerial mapping camera, which is a single lens, reconnaissance camera, strip camera, panoramic camera, multi-lens camera, multi-band aerial camera, digital cameras. Aerial films. Aerial films is a multi-layer emulsion laid on a stable anti-halation base. Generally, aerial films are available in the rolls that has cross-section of about 10 inch in width and 200 to 500 feet in length. Types of films. Depending upon the suitability for different purposes and unique situation, variety of films are available that are used. Panchromatic and natural color films are the two most commonly utilized films. These two films along with infrared and false color form the basic media used in area photography. Panchromatic. Panchromatic, more often termed as black and white, is most commonly encountered film employed for photogrammetry. The sensitive layer consists of silver salt, which is bromide, chloride and halide crystals suspended in a pure gelatin coating which sits atop a plastic base sheet. The emulsion is sensitive to the visible spectrum, that is 0.4 to 0.7 μm portion of the electromagnetic spectrum. Color films. Natural color, also known as true color films. The multi-layer emulsion is sensitive to visible region of electromagnetic spectrum. They are 3 layers of gelatin consisting sensitized dyes, one each for blue, green and red light. Green and red light are also sensitive to blue wavelengths. Visible light waves first pass through and react with the blue layer and then pass through a filter layer which halts further passage of the blue rays. Green and red waves pass through this barrier and sensitize their respective dyes, causing a chemical reaction and thus completing the exposure and creating a true color image. Infrared film. Current aerial infrared film is offered as two types, black and white infrared and colored infrared. Black and white infrared have the emulsion sensitivity to green, red and the parts of near infrared portions of the spectrum and renders a grayscale image. Colored infrared. Colored infrared film is commonly termed as false color. The multi-layer emulsion is sensitive to green, red and parts of the near infrared portions of the spectrum. A false color image contains red-pink hues in vegetative areas with color depending upon the degree which the photosynthetic process is active. Flight direction. It is advisable that aerial photography is flown in tiles to cover the chosen area in a designated flight line. For easiness in handling, it is prudent to keep the number of tiles to minimum. The flight direction of the strip or tiles is therefore kept along the length of the area. This direction may be any suitable direction along natural or man-made feature and should be clearly specified. Further, transmission process and the data collection. Time. The time at which aerial photograph taken is very important, as long the deep shadows tend to doubtful details, whereas undersized or small shadows tend to mark out some details effectively and are generally fruitful in improving the interpretational values of the photographs. Based on experience, aerial photography should be flown when the sun elevation is 30 degrees above the horizon or 3 hours before or after the local noon time. Season. Factors such as seasonal variation in the light reflectance, seasonal change in the vegetation cover and seasonal change in the climatological factors are the tip points for choosing the suitability of the season. The purpose for which aerial photography is flown also dictates the season. For example, for photogrammetric mapping, geological or soil survey purpose, the ground should be as clearly visible as possible. Atmospheric conditions. As mentioned, the presence of the particles, that is smoke, dust or molecules of gas in the atmosphere tend to reduce the contrast because of scattering, especially by the heavier particles. Therefore, the best time for photography is when the sky is clear, which normally in India is from November to February. The presence of dust and smoke during the pre-monsoon summer months and of clouds during the monsoon months forbids aerial photography during these periods. Stereoscopic coverage. To examine the Earth's surface in 3 dimensions, aerial photography is normally flown with 60% forward overlap and 25% side overlap to provide the full coverage of the area. This is an essential requirement for the photogrammetric mapping point of view to obtain data both on planimetry and heights using the stereoscopic principle of observation in 3D and measurement techniques with stereo plotting instruments. Stereoscopic viewing also helps in interpretation as a model is viewed in 3-dimensional. Classification of aerial photographs. There are different criteria to classify aerial photographs. Different criteria are scale, tilt angle, angular coverage, type of film and spectral band. Depending upon these criteria, aerial photographs can be classified as based on scale. Large scale between 1:5000 and 1:20,000. Medium scale aerial photographs, that is between 1:20,000 and 1:50,000. Small scale, that is smaller than 1:50,000. Camera orientation. Based on the camera orientation, the aerial photographs can be divided into vertical. When the vertical photograph is taken, it is evident that optical axis of the camera should be vertical or nearly vertical, where the tilt is within 3 degrees. The result is coincident with the camera axis. A vertical photograph has the following characteristics. Lens axis is perpendicular to the surface of the earth. It covers a relatively smaller area. The shape of the ground area covered on a single vertical photo closely approximates a square or rectangle. Being a view from above, it gives an unfamiliar view of the ground. Distance and direction may approach the accuracy of map if taken over a flat terrain. Relief is not really apparent. Oblique. Based on oblique is being divided into low oblique aerial photographs. Photograph is taken with strongly tilted optical axis but not to the extent that horizon appear in the photograph. Horizon does not appear but tilt is more than 3 degrees. Low oblique has the characters such as it covers a relatively smaller area, the ground area is covered is trapezoid, although the photo is square or rectangular. The objects have more familiar view compared to the viewing from the top of a hill or tall buildings. No scale is applicable to the entire photographs and distance cannot be measured. Parallel lines on the ground are not parallel on this photograph. Therefore, direction, which is the azimuth, cannot be measured here. Relief is discernible but distorted. It does not show the horizon. High oblique. In this, the photograph is taken with deliberately tilted optical axis enough from the vertical to show the Earth's horizon. The horizon appears in the photographs. High obliques has the characteristics such as it covers a very large area, not all usable. The ground area covered is a trapezoid, but the photograph is square or rectangular. The view varies from very familiar to unfamiliar depending upon the height at which the photograph is taken. Distance and direction are not measured on this photographs for the same reason that they are not measured on the low oblique. Relief may be quite discernible but distorted as in any oblique view. The relief is not apparent in the high altitude high oblique. The horizon is always visible. Horizontal or terrestrial. These photographs is taken with the camera axis horizontal. Convergent photography, it is a sequential pair of low oblique in which the optical axis converges towards one another. In this kind of photography, both the photographs cover the same area but from different locations. Angular coverage. Angular coverage is a function of focal length and format size. Narrow angle. Angle of conversion less than 200, that is large focal length used for general interpretation, intelligent and mosaics. Normal angle. The angle of coverage between 500 to 750 is used for general interpretation, mapping, orthophotography and mosaic. Wide angle. Angle of coverage is between 850 to 950. Used for general interpretation, general purpose photography for normal terrain, resource mapping and mosaics. Super wide angle. The angle of coverage more than 1100 is used for general purpose mapping of flat areas. Film. Black and white panachromatic. This is most broadly used type of film for photogrammetric mapping and interpretation. Black and white infrared. This is used to interpretation and intelligence and in hazy environment as IR can penetrate through the haze. Color. This is used for interpretation and mapping. Color infrared or false color. This is used for vegetation studies, water pollution and crop studies. Spectral coverage or response. Multispectral. Depending upon the number of spectral bands are used in aerial photographs. Obtaining aerial photography. As per the existing policy of the Government of India, all types of aerial photographs are classified documents, which is either kept secret or it is restricted for the public use, depending upon the location and its strategic importance. The Surveyor General of India coordinates all activities related to the execution of aerial photographic tasks for all civilian needs. The coordinating authority performs certain functions like design and issue of a specification for photographic task, layout and priorities, clearance from various agencies and distribution of tasks among the 3 flying agencies, flight planning and evaluation for suitability of executed task, distribution of photographs to the inventor, accounting for all the above. Remote sensing versus aerial photographs. The remote sensing in aerial photograph acquires the information from the measuring the electromagnetic radiation from the airborne systems. Their differences are Data capture. Aerial photos are taken by an analog instrument, that is a film of a camera, then scanned to be transferred to digital media. Remote sensing data is usually gathered by the digital CCD camera. Resolution. Comparatively, the remote sensing system has high resolution which can be integrated into the physical equation of the energy balance. For example, projection. Aerial photographs are central projection with the whole picture taken at one instance. Remote sensing images created line after line, therefore the geometrical correction is much more complex, with each line needing to be treated as a central projection. Electromagnetic radiation. Aerial photos usually get the data only in the visible spectrum, that is, they are also special film sensitive to the near infrared radiation, while the remote sensing sensors can be designed to measure radiation all along the electromagnetic radiation. Disturbance. Both systems are affected by the atmospheric disturbances. Aerial photos mainly form, that is, scattering of light, the process which makes the sky blue. Remote sensing images also form process of absorption of atmospheric correction to aerial photographs can be done by remote sensing. Thermal remote sensing sensors can operate also at night times, and radar data is almost weather independent. Difference between a map and an aerial photograph. A map cannot be directly traced out of an aerial photograph. The reason is that there is a basic difference in a planimetry, that is projection, and the perspective of a map and an aerial photograph. The difference is the aerial photographs are having a central projection, whereas maps are orthogonal projection. An aerial photograph is geometrically incorrect. The distortion in the geometry is minimum at the center and increases towards the edges of the photographs. A map is geometrically correct representation of a part of the earth projected. The scale of the photograph is not uniform. The scale of the map is uniform throughout the map extent. Enlargement or reduction does not change the contents of the photographs and can easily be carried out. The enlargement or reduction of the map involves redrawing it afresh. Aerial photography holds good for inaccessible and inhospitable areas. The mapping of inaccessible and inhospitable areas is very difficult. Aerial photography in India. Aerial photography in India goes back to 1920 when large-scale aerial photographs of Agra city were obtained. Subsequently, Air Survey Party of the Survey of India took up the aerial survey of Irrawaddy Delta Forest, which was completed during 1923 to 24. Subsequently, several similar surveys were carried out and advanced method of mapping from aerial photographs were used. Today, aerial photography in India is carried out for the entire country under the overall supervision of the Directorate of Air Survey, that is the Survey of India, New Delhi. Three flying agencies are Indian Air Force, Air Survey Company, Kolkata, and National Remote Sensing Agency, Hyderabad, have been officially authorized to take aerial photographs in India. The procedure for inunding aerial photographs for educational purposes could be made with APFPS Party number 73, Directorate of Air Survey, Survey of India, West Block, Delhi. Summary. Aerial photographs presents the bird's eye view of the earth in the central projection and are proved to be commanding tool for studying the earth's feature. They are useful for cartographers and planners to gather detailed measurements from aerial photographs in the preparation of maps. Skilled interpreters make use of aerial photographs to determine land use and other phenomena on the earth. Aerial photos have high degree of radial distortion. The topography is distorted, and until corrections are made for this distortion, measurements made from the photographs are not accurate. Aerial photographs are first-rate data source for many types of projects, particularly those require spatial data from the same location at periodic intervals over the length of time. Aerial photographs are used in topographical mapping and interpretation. These two different uses have led to the development of photogrammetry and photo or image interpretation as two independent but related sciences. Photogrammetry, it refers to the science and technology of making reliable measurements from aerial photographs. The principles used in photogrammetry facilitate precise measurements related to the length, breadth and height from such photographs. Hence, they are used as the data source for creating and updating topographic maps. Image interpretation, it is an art of identifying images of object and judging their relative significance. The principle of image interpretation are applied to obtain qualitative information from the aerial photographs such as land use, land cover, topographical forms, soil types, etc. A trained interpreter can thus utilize aerial photographs to analyze the land use changes.